Okay, so in this video, we're going to take a look at that factoring review, specifically questions 11 through 15. So with question 11, it's already written here, can be disguised. It is a little bit disguised, but what we can do is rewrite the question to look like this. 25x squared minus 4. And then this we should recognize as being a difference of squares. Okay, and so we have a rule for that: square root the first, square root the last. And the catch with difference of squares versus perfect square trinomials is that there will be no middle term for difference of squares, right? So I just get to go 5x and 2, and I'm going to write this twice for difference of squares. 5x and 2, and we're going to have opposite signs in either bracket in order to, if we were to expand it, eliminate that middle term, okay? The b term, or the term with x on it, okay? So that's number 11. So number 12. Number 12 says it's y cubed minus 2y plus 3y squared minus 6. Okay, so this to me, nothing fancy here. I think this is just going to be factor by grouping. Okay, so I'm just going to group the first two and group the last two and look at what's common across each term specifically, or each pair of terms. So in the first two, it looks like I can remove a y. And so I'm just going to remove a y, and then I'm going to write y squared minus 2. And then over here on the other piece here, I'm just going to remove what looks to be a common factor of 3, and I'm going to write y squared minus 2. And look at that, the two pieces match. Okay, at which point you can factor out the y squared minus 2 to the front and write what's left, the y plus 3. Okay, again, that's factoring by grouping. Okay, question 13 says it's 3y squared minus 9y cubed. Okay, again, I don't think it matters too much, but I'm just going to rewrite this to be 9y cubed plus 3y squared, just to write it in descending order. Remember, we talked about descending order being highest degree to lowest degree in a polynomial. And so I can remove, it looks like maybe negative 3y squared, right? Just for as sake and consistency and formality, we'll remove and make sure that the leading term does not have a negative on it. So we'll say negative 3y squared is the common factor, and when I remove negative 3y squared from each of the terms, I'm going to get 3y minus 1, sorry. Okay, and that's that. Question 14. Question 14 will say 5 plus 6x plus x squared. Now, a lot of the time, I think that they're just trying to trick you with the order of things. Like, remember, it's just good habit or good practice to write things in descending order and follow a process that you know. Okay, so that looks like a simple trinomial. Okay, and sorry, I got to go back here for a second. This is just, number 13 is just a common factoring question. Okay. All right, so simple trinomial. Okay, and with a simple trinomial, I'm going to use my Mann method to satisfy the conditions, right? The two conditions I'm trying to satisfy is multiply to 5 and add to 6. So I just run through my routine of, okay, the two numbers that satisfy the multiplication condition, right, or a potential pair would be 1 and 5. Because 5 is prime, this is the only combination of multiples that satisfy, and so the addition term has to work out with those two factors. Okay, and because it's a simple trinomial, we like simple trinomials because as soon as I find these two factors, I can write them in my equation in what we called factored form last year. Okay, so that's number 14. That's a simple trinomial, and number 15 is 18x squared minus 25x minus 3. Okay, there's no way for me to turn this into a simple trinomial or remove any common factor simply because there's no common factor between 25, 18, and 3. So we're stuck having to use the complex trinomial method. Okay, and so we're looking again to identify the factors that multiply to negative 3 times 18, which will be negative 54, and add to negative 25. Okay, and so we're going to satisfy these conditions by running through all the possible factors, right? And eventually we'll find 2 that work, hopefully, if it's factorable. So 1 and 54, obviously never going to add to negative 25. 2 and 27, oh, that's not bad. So 2 times 27 gives me positive 54. We know we need negative 54, so one of those 2 factors needs to be negative. For the sake of argument, let's, as well as add to negative 25. So I'm going to say the 2 is positive and the 27 is negative, right? So when I multiply positive 2 and negative 27, I get negative 54. And when I add 2 and negative 27, I get negative 25. So these are my 2 factors. Now, nice having question 14 and 15 back to back like this because you can see very clearly the difference between what a simple trinomial is and what a complex trinomial is, and the processes that we need to use in each of these instances. Okay, so we like simple trinomials because as soon as we find those factors, we can just put the 2 factors after the variable and move on. With complex trinomials, they're called complex for a reason. We cannot do that. We need to use a process called decomposition. Okay, and with decomposition, we're going to decompose that middle term to be, and by decompose the middle term, it includes the variable that's on it, right? So we know we're going to decompose negative 25x into 2x and negative 27x. Okay, when I add those 2 things together, I get the 25 back. That's why we're calling it decomposition. We're breaking that middle term down into its 2 pieces, okay? And then I'm going to write either piece, the other 2 pieces, terms on either end, okay? And now we're just factoring by grouping, okay? So we're just going to find what's common in the first 2 terms, find what's common in the second 2 terms. If we do it correctly, we should see some sort of common factor appear across each half. So common across the first 2 is 2x. What's left after I remove the 2x is going to be 9x plus 1. What's common across the second 2? It looks like negative 3. What's left after I remove the negative 3? It'd be 9x plus 1. So we can see there the same piece appeared twice. That common piece across each, here's one term, here's the other term. That shared yellow piece is the piece that we can now remove or common factor out. 9x plus 1 multiplied by what's left after I remove it, 2x minus 3. And that should be the answer for question 15.